Hello everyone, myself is Dinesh and my roll number 536 and my topic is about moving toward 5G, significant differences and impact on quality of experience. And we witness an explosive growth in the volume, velocity and variety of data available on the internet. Such data explosion is mostly caused by the mobile devices, sensors, actuators and social networks. The ever-increasing demands of users related to high storage, fast computation, and processing has led towards the innovation of 5G technology. A paradigm shift has occurred in the information and communication technology ICT sector. New technologies such as edge computing, fog computing, and IoT are emerging and evolving with time. In a very short span of time, the cyber development and advancements have completely changed the way of how we work, play, teach, and learn. Despite such tremendous growth, the quality of experience QoE of the users are barely met. Monitoring and evaluating the provision network services is an area that has currently received a growth interest by industry and academia. The reason for such development is the thriving contention among the stakeholders in ICT, media, the abundance of resource intensive services, online video and virtual reality video streaming and recommendations, and the ultimate risk of customer churn lost caused by inadequate service quality. In order to leverage users QoE, the vendors have to adopt new efficient technologies to outsmart the competitors to provide specified quality of service QoS attributes. The vision of information on the fingertip and restricted mobile computing allows the need to enhance computing power of mobile devices to meet the insatiable computing demands of mobile users. It has been estimated that by the year 2020, the number of IoT devices will increase from 10 billion to 34 billion, and nearly 6 trillion will be spent on IoT solutions in next 5 years. Considering the ever increasing demands and requirements of the mobile users, the communication networks has evolved tremendously from the start till now. The first generation 1G was based on analog technologies which is currently no longer is used. The second generation 2G was introduced to industry after 1G that was based on digital technologies. The third generation 3G standards were introduced next should be capable of handling around 2 megabits per second. The fourth generation is able to process at least 100 Mbps and up to 1 gigabytes per second. The 4G or LTE is today's modern cellular technology. 5G is the latest generation of communication networks that is targeted to first is deliver high rate data and reduce latency and energy and cost efficiency and enormous device connectivity. 5G networks are expected to operate in low frequency spectrum such as 600 MHz as well as unlicensed frequency band of 3.5 GHz. Quality of experience. The internet has transformed from being infrastructure oriented, such as Ethernet routers and computers, to business oriented, Facebook, Google, and Amazon. Moreover, after the inception of mobile technology, existing computing models such as cloud has to undergo several modifications to deliver the specified QoS and to meet the QoE criteria of the end users. The objective of the aforesaid computing models was on performing data processing at the network ends away from the centralized nodes, providing the best effort services by ignoring the network mechanism is not enough to satisfy the customer requirements. In an experiment by Google, a 20% revenue loss was reported due to delay of 500 milliseconds in responsive time. Moreover, Amazon reported a sales decrease of 1% due to an additional response time of 100 milliseconds. There is a growing trend that service-oriented attributes like QoS, quality of service, does not cover every aspect of the application performance related perspective. The current computing models, such as fog, edge, and IoT, are based on services, and those services are accessed by users. Being closely related to the perception of the end user, quality of experience is supposed to capture a broader, more holistic view of impact and performance of communication network. Edge fog, IoT, and cloud architecture features similarities and differences. The IoT is undoubtedly the future of internet. Studies have proved that the edge and fog computing based services will play a pivotal role in extending the cloud. The exponential growth of data, specifically time critical data coming from the underlying IoT devices, needs, needs to be processed closely to the proximity to avoid unnecessary data delays and to improve responsive time. Companies are now exploring fog, edge, and mist computing to catch up with increasing demands of the users. The edge devices are connected with the fog through sensors or actuators. The fog provides the communication network to perform the tasks. Depending on nature of the task, fog decides either to execute the task on-site or to redirect it to the cloud. Edge computing performs computation at the edge of the network, serving as a proxy between things, devices, and the cloud. To, to goal is to deliver processing and storage functionalities to IoT devices. Unlike fog, edge computing devices does not always work with a cloud. Some limitations of edge are less capable proprietary network interconnections, no resource pooling, and no extension to information and operational technology team. Fog computing has more intelligence and computations at a LAN level, local area network level, pre-processing data in fog node or in IoT gateway. Distributed computing is performed where any device with network connectivity, computing, and storage can become a node. Fog computing is capable to do real-time data analysis and to perform immediate actions, privacy of sensitive data, scale, and be cost-effective. A major drawback in fog computing environment is the number of links involved for the data transmission, which can potentially be a point of concern. IoT is simply is a network of devices having some mechanism to connect with other devices. The devices can communicate with other devices through internet and can be remotely controlled. IoT transforms capital expenditure into operating expenditure. No internal system administration, reduced development and deployment cost, fault tolerant and scalable. Apart from several benefits, IoT has been criticized for platform fragmentation, privacy, autonomy and control, storage, security, and interoperability of standards. 5G impact, realities, and concerns. Impact. Considering the attributes of 5G stated in introduction section, the impact of 5G on the current market can be assessed by the change in the it can bring to the existing communication networks. The performance of 5G will be evaluated by different applications, placing different requirements on performance, where the peak requirement under certain configurations has to be satisfied. For example, data intensive applications such as HD video streaming can tolerate latency and reliability criteria, whereas in autopilot cars, the same criteria is of utmost importance. Comparatively, 5G will be able to increase the aggregate data roughly 1000 times than 4G, meaning networks will be able to serve more bits per second, resulting in better true output, response time, and less congestion. Latency is another impact aspect in networks. Existing 4G or LTE round trip are approximately 5 milliseconds based on 1 millisecond subframe time. 5G can operate in small spectrum, which means 5G should be cheaper 10 to 100 times per hertz as compared to 4G. 5G is anticipated to reduce 90% of network energy consumption as compared to existing network. Concerns: the 5G technology is equipped with all the features and functionalities to shift the computing paradigm. However, there are certain obstacles that may hinder in the successful enforcement of 5G, such as architectural constraints, security, and adoption. In order to provide low latency and high response time, 5G has to adopt device-centric architectures as compared to traditional base station-centric architectures. Multiple input, multiple output MIMO is under disruptive technology that will play a central role in 5G. One of the main limitations is the channel estimation. The movement imposes a challenge to acquire challenge knowledge and utilize it in a small interval time. There are some other issues related to MIMO, such as channel model, elevation beam forming, and coexistence with small cells. Apart from architectural issues, there could be design issues that require attention. Moreover, to ensure trustworthiness of the network, 5G must be able to provide privacy of data and identity, secure communication, identity management for identification and authentication of the users, resilience to attacks and malicious activities, and security assurance of the equipment and standards adopted. Older versions of mobile devices may not be able to receive 5G signals as it requires specific set of antennas which are not available to them. 5G can have specific impact on the quality of experience of users. However, users are reluctant to adopt new technology and pay more, assuming that their regular needs are fulfilled at satisfied level by the existing technologies. Conclusion: the emerging paradigm of 5G certainly have features and capabilities to improve users' quality of experience by overcoming the limitations of existing technologies. However, 5G is still in its infancy stages of development and deployment. A lot of architectural design and technological advancements have to be made to successfully implement 5G technology. There are several research areas that can be explored in a foresight perspective. Some areas of attention are security and privacy of data, channel estimation in movable nodes, interoperability of devices and standards, D2D and end-to-end communication without interference, and architecture enhancements in the existing infrastructure. That's it, and thank you, everyone.